Suppose the local population of a certain insect was estimated to be 4.8 million in 1952 and 11.4 million in 2002. We're going to do this problem basically two different ways. So first, calculate the unit rate of change of the population per year. All right, so the way we've been doing these problems is we find the oldest year and we say let x equal 0 for 1952. So that ordered pair would be 0, 4.8, where the y value is represented in millions. And then we say, okay, 2002, well, that's 50 years after 1952, so that x values would be 50. Got to have the same difference between each piece. So in 50, we'd be at 11.4 million. Now with two ordered pairs, I can find, here's x, here's y, change in y minus change in x. So I end up with 6.6 over 50 for a slope value of 132 thousandths. So there's my unit rate of change. Okay, we're going to need that, so hopefully you write that down somewhere. Construct a linear model. Okay, now if we're assuming 1952 is the starting point, then my y-intercept is 4.8. So I've got y equals 0.132x plus 4.8. Because the starting point is 1952, so there we go. So here's my model. Use your model, and our model again is 0.132x plus 4.8 to calculate the insect population for 1992. Well, remember, x equals 0 was for 1952. So 1992 is 40 years later, so x is 40. So if I go to my equation and I plug in 40 for x, okay, so multiply 0.132 by 40, I get 5.28 plus 4.8. I end up with 10.08. And again, my y values are in million. So for 1992, we would have approximate population of 10.08 million. Right? And that's everything we've done so far. It's okay, let's kind of think this. So far, we've always done the starting year with x equals 0. But sometimes you can change it so that x equals 0 is literally year 0. And that's what we're going to kind of play with in the second part of this example. We are going to replace y, x, and m in the y equals mx plus b formula with the slope we found in number 1, which was 0.132, and then this point. So here's x and here's y, and we're going to solve that equation for b. So y equals slope times x plus b. So all I did was I put this in for x into the formula, I put this in for y, and this one into my m. And now we solve. Now our goal here is to get b by itself. So first things first, I'm going to multiply these pieces together. And so I end up with 11.4 equals 264.264 plus b. If I want to get b by itself, I now am going to subtract this piece. Is that really a 2? Let me check my math. Hold on a second. Sorry, sometimes I can't read my handwriting, so I want to double check I had the right number there. So we're tracking 264 from both sides, and I end up with a y-intercept of, find the right spot, negative 252,864. Right? So in the year 0, that's how many insects we would have. Which seems very, very odd, but year 0, you know, what is that? Right? Okay, so now we have a y-intercept and we have a slope. So we can write our new model. So y equals our slope, and then our new y-intercept we just found, negative 252,864. So this assumes the year is exactly what the year says. Exactly what the year says. So for 1992, our x value would be 1992. So using this equation, all we're going to do is take this exact year and plug it in for x. 132 times 1992. So I multiply these first, and I get 262.944. Subtract my big y, well, I guess it's a small y-intercept, but when I subtract these, I end up with 10.08 million. The exact same value we found in number 3. It's the exact same. So we did it a little bit differently. We used the same slope, but we had different y-intercepts because we were using different values for x, right? Which is kind of nice. So you can do it either way. You just kind of have to pay attention. And so basically, I always say if your y-intercept looks funny, like it doesn't look like it fits, then you're probably just using the actual year. Okay, now let's do the same thing. Let's solve for b again, but let's use our other point. So we're going to use y equals, my slope, as we know, is 0.132. My x value now is 1952, and we're going to solve for b. So we're just going to say, what would have happened? What would have been our y-intercept if we would have done it the other way? Well, if I multiply these pieces together, I get 257,664. And we want to get x by itself, or b by itself, excuse me. So we're going to subtract the 257,664 because these will cancel out. I'm just left with b. And when I subtract, I get negative 252,864, which is the exact same y-intercept we found using the other point. So because they're linear, it doesn't matter which point you use, you would get the same answer either way. And that's 2 different ways to solve the same linear equation problem.